Okay, so this is going to be, we're going to look at methods to try and find rational roots for a polynomial equation. And so the rational root theorem is what this is called sometimes. And in this case, they're calling it the rational zero theorem. Those can be used kind of interchangeably. And you should get in more of the habit if you are going to have to take more math classes or even another math class. You want to get used to, because people that you are going to be going to college with will have more background in some things than you have. And a point in case is one of my daughters, what did she take at Mankato West? She took AP Calculus, the first semester of that at Mankato West. But when she went to the University of Minnesota and took Calc 2 fall semester of freshman year, and she said something about some of her work or whatever, and I said, well, get in a study group with some of your kids. And she said, Mom, practically my whole class is high school students. That's because in that area, Minneapolis, there's a lot more opportunities, and people who are doing PSEO there maybe are taking their second semester of calculus while they're still in high school. So you want as big of a background as you can get. So if f is a polynomial function of the form, and you want to just kind of be used to seeing this format, so you want to write it down. F of x equals a sub n x to the n plus a sub n minus 1, just meaning it's the next term down, x sub n minus 1. And if we kept writing them, it would be a sub n minus 2 to the x to the n minus 2. But then we just go plus dot 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 plus a sub 2 x squared plus a sub 1 x plus a sub 0. And we know some of those could be 0 coefficients, so they wouldn't be listed there. But certainly there's some degree that has to happen. So this has to have a degree greater than or equal to 1. And obviously, you know, if it's just a constant number, or if it is, you know, 5x plus 3, that's going to be pretty easy to figure out. And it has to have integer coefficients. So, you know, if this is 1/2, a sub n is 1/2, then we have to multiply everything by 2 to make it all to integers. And that should be okay when we have something set equal to 0. And the last term is not 0. That means there's no common factor of x. If a sub 0 was 0, there would be a common factor of x. We would factor that out. Likewise, if there's a common factor of 2 or some number, we would factor that out as well. Then every rational 0 of f has the form P over Q. And to start with, you'll just be asked to list P over Q. And here's what P over Q is going to be made out of. P and Q have no common factors other than plus or minus 1. And P is the integer factors of the constant term a sub 0. So P is the factors of the constant. And Q is the integer factor of the leading coefficient. And so Q is the factors of the leading coefficient. And make sure you're ignoring the x part, x to the 4th or whatever it happens to be. And so this P over Q fraction is going to be all the factors of these things over all the factors of this. So it should just make sense immediately, since you're writing this as a fraction. We're going to be happiest when the leading coefficient is 1, right? Because if the leading coefficient is 1, then there are no fractions that we have to do synthetic division with. They're all going to be integer numbers. So that's this corollary. And I don't know, in this class we don't have many corollaries. In geometry we did. When there's a big theorem and then kind of an important point or case, then sometimes that's given as a corollary. It's kind of a miniature theorem related to the big theorem here. And this is the one that I said was our most desirable situation. If the leading coefficient a sub n is 1, then the rational zeros of f are integer factors of the constant term a sub 0. So once we know all the possible rational zeros, then we start our process of synthetic division to find them. And if you remember, once we find one, we get that depressed polynomial. So we get a little shorter version to kind of divide. And we just kind of continue to do that as we get down. And then once we get down to a quadratic, we can either keep doing synthetic division or we can try to factor it. Do you know what I mean? And later on, when we're looking for more than rational roots, and we're looking for complex roots or irrational roots, we'll use the quadratic formula also so that we can find all the zeros. So really, our goal is to take a higher power polynomial than a squared quadratic and to be able to find all the roots eventually. So right now we're focusing on rational roots. So right this minute, we can only write all of our P over Q values and just try all those. As time goes on, and we kind of have to learn it step by step, we'll have kind of some ways to eliminate some of those or decide which ones to try first. You know what I mean? But right now, we'll just try them as we go. So here's the first one, 1A. And we start by just listing all the possible rational zeros. So f of x is x to the third minus 3x squared minus 2x plus 4. This is the only one that I will really write out what p over q is. Otherwise, I'll expect us just to be able to do that. So p is the factors of 4. P is the factors of 4. So that is, and the way we'll always write them is plus or minus 1, just with that plus or minus in front because we get both, plus or minus 2, and plus or minus 4. And then Q, in this case, and maybe I'll use a different color marker and I'll just write a 1 there. Q is the factors of the leading coefficient, so it's the factors of 1. Factors, in this case, of 1, which is just plus or minus 1. So then really what we're asked for here is this fraction of P over Q. So, and again, this is the most I'm ever going to write for P over Q. From now on, I'll just write P over Q and boom, start writing out all the possibilities. So we take, it's a fraction, any of these, plus or minus 1, plus or minus 2, plus or minus 4, over any of these, plus or minus 1. Well, this is a pretty straightforward one because there's not, 1 over 1 is 1, 2 over 1 is 1, or excuse me, 2 over 1 is 2, 4 over 1 is 4. There's no fractions. So then we can just say P over Q equals plus or minus 1, plus or minus 2, and plus or minus 4. And so that's the P over Q to list all the possible rational zeros. So that's the P over Q part for this problem. Then the next thing we do is just try them and do that long synthetic division. And I did all of them for this one. I think I'm going to not do that this time as we go through because we're going to find, what would you try first? Here's your choices. What would you try? 1, yeah, that's what we're going to try. And I think 1 works, or maybe it's -1, I can't remember. But then this is only to the third power, so once I get 1 root, I'll have a quadratic, and then I can just see if it factors, or I could, if I wasn't sure, I could put it in the quadratic formula or whatever. So this is part 2, and I'll write with this. This is to determine which, if any, are zeros. Now, you have to pay attention to directions. This just says, list these out, figure out if any of these are zeros. So it's not asking us to find anything that's irrational or complex at this point. And so we're just kind of trying the ones that would possibly work here. And so I just want to see this amount. And I'm going to ask that we'll all do this first one long out. A and B, I'm going to do the regular way. And then when we get, or the first two problems, I'm going to do the regular way. And then when we get to the third one, we have a lot of things to try. And so we're going to, we'll shorten that up. So it's important to me that you do these first couple and just write them down to kind of get back in that rhythm before we go to the kind of shortened version. So we would try 1 first, and 3, 2, 1, 0. So all the terms are accounted for. 1, -3, -2, and 4. And I'll draw my line. I bring down my 1. 1 times 1 is 1. -3 plus 1 is -2. Times 1 is -2. This is 4. And maybe I made a mistake. It is -4. That was my mistake. Thank you. And because I think I was multiplying them actually. -4 is -4, and I get 0. So this one did work right away. And then our other polynomial part is x squared minus 2x minus 4. And so this is something we can try to factor. Could I continue doing synthetic division? Absolutely. Does this factor? Take a minute. Can I find something that multiplies to be -4 and adds to be -2? Multiplies to be 4. And the only things that multiply to be 4 are 1 and 4, which would either add to 5 or subtract to 3, and 2 and 2, which either add to 4 or subtract to 0, right? So this can't factor, and I'll just write that there too, can't factor. So the only one of these out of this list that is a 0 is that +1. And so we could have also done synthetic division and tried all of those and figured out, that none of those work as well. So our next one is pretty straightforward also. You'll like it. It doesn't give us a lot of rational things to try. And so it'll be a short problem to do, but there is one thing to be careful of here. And so this is 1b, and it is f of x equals x to the third minus 2x minus 1. So now I just want p over q. So p is the factors of -1. They are only plus or minus 1. And q is the factors of the leading coefficient, that one in front there, and that is also plus or minus 1. So if I have plus or minus 1 over plus or minus 1, the only things I can try are plus or minus 1. Now, take a minute, set up, we'll just do 1 first, it doesn't really matter. Set up this synthetic division problem. And do you want me to say anything, or do you want me to have you try it? Okay, go ahead and try it. No. 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 There we go. There's one. There's one. There's 2 people doing it right on that side of the room. No. Where is it? Let me. Yep. Let me see. Okay. Nope. 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 Hard for me to see. Yes. Nope. Nope. Okay, a whole bunch of people are missing something. What are they missing? Okay, so I'll give you the hint now. 3, 2, 1, 0. What's missing? There's no x squared term, right? So when I do my synthetic division, I have to go 1, 0, -2, -1. So we have to just be careful of that. And listen, are we going to know if that's the case? No, because, you know, it just won't work, or maybe some number will work that isn't a 0. So I bring down my 1, 1, 1, 1, -1, and -1, -2. So does this one work? No. And so then we'll try -1, 1, 0, -2, -1, and 1, -1, -1, 1, -1, 1, 0. Oh, this one works. So when we are giving our two answers, I'll just rewrite this. P over Q is ±1, and the 0 out of these two choices is -1. And so we're just finding the zeros out of this. We're not kind of looking any further. Now you'll see why I'm going to shorten this process up with our next problem. And my first synthetic division, I'll do just like this, and then we'll convert to this other method. If you like the other method, great. If you don't like it, just do it all like this. It's the exact same thing. We're just going to write a little bit less down on some of our problems. So here's our next one. This is number 2. F of x is 2x to the third. So right away, Q is going to have some fraction factors. Minus 5x squared minus 28x plus 15. And same thing, decide the number of possible rational zeros, and then see if any of those are zeros. So P over Q is equal to, well, this is 15. So I need all the factors of 15 for P, ±1. And I generally write them, actually, I don't write them low to high. I write them low to high integers, and then I write all the fractions after that, any fractions that I have. So P is ±1, ±3, ±5, and ±15. Put some commas in there. And Q is the factors of 2, so ±1 and ±2. So my favorites are the ones that are this ±1, because these will just be the whole number integers that I'm going to get. So my P over Q, I get all these over 1, so ±1, ±3, ±5, ±15. And then I have to see what I have for fractional choices. And sometimes we're lucky, and like there might be some even numbers up here, you know, that will reduce to a whole number, but not this time. So our fractional choices are ±1/2, 3/2, 5/2, and 15/2. So ±1/2, ±3/2, ±5/2, and ±15/2. So that's part 1 of my answer, just to give those values. And then I just like to work my way through. At this point in my life, I just work my way through from here to there. And when I get down to like a quadratic, I might factor that. Or I might try another one. And there are times that I look at the pattern at the end and see what's happening and kind of say, I'm going to give up on that kind of number and pick something else. So the first one we'll do just like we have been. So here's my box. We'll try 1 just like always. 2, 3, 2, 1, 0. So 2, -5, -28, and 15. I draw my line. I bring down my 2. This is, and then I'm going to say it this way. 2 minus 5. Oh, no, I'm sorry. 2 here, and then -5 is -3. And then -3 here, and -28 is -31. Yeah. And then -31 and +15 is minus 16, I think, right? I started to do it the short way in my head, but so I'm gonna slide this quite a bit down because all I need to see right now is these, and I've got this stuff. So here's how we're gonna shorten this up. Essentially, we are not gonna write that. So we're gonna lay it out a little different because if this didn't work, when I try the next one, I'm not ever going to rewrite this. I write this out one time. So it's on a row by itself now. And then I'm going to put this just down a little bit. And in a way, this is going to be gone. It's like I'll put it right there. So here's how I'm going to do this in a shorter way. 2, -5, -28, and 15. I'm going to draw a line there. And at some point, when I get done with that, I sometimes draw a line through it because otherwise my eyes kind of look back up at it. I'm now going to move my 1 to right here because I'm just writing the bottom row there, okay? So I'm just writing the bottom row there. And now I'm either going to do a little more in my head or with a calculator. It all works the same. So I still bring down 2, correct? So I bring down my 2, but then I just do a little more in my head or with a calculator. So 2 times 1 is 2. What's 2 minus 5? -3. So I'm just writing my answers. And then -3 times 1 is -3, minus 28 is -31. -31 times 1 is still -31, plus 15 is -16. So it's the exact same thing, it's just a little shorter. Now here's what else we do. If that had been 0, I'll just pretend for a minute it was. If that was 0, I'd cross it out, and then I'd cross this out, and this would be my new row. Do you agree? And then I just would go down from there. Since this one didn't work, what I do is I just cross that whole line out because then I know 1 did not work. And so now we'll just keep trying some more. Luke, what do you want to try next? I have this whole list of things. Do you want to go? And usually I either go to -1 or +3. I don't care. Okay, so we'll go to 3. And so now let's just kind of process that a little slow. So we bring down the 2, and then 2 times 3 is 6, minus 5 is what? 1. And then 3 times 1 is 3, minus 28 is what? Minus 25. And then -25 times 3 is -75, right? And so actually, do I even have to figure this out? It's not 0, right? So I'm just going to say, nah, that one's not going to work. And so I've tried 1 and I've tried 3. Let's try, now I'll go to maybe -1 and -3, see what happens. I bring down my 2. I'm still using this top row. 2 times -1 is -2, minus 5 is -7. -7 times -1 is 7. Minus 28 is what? -21. Positive 21 and 15, is that going to be 0? No. So I can even kind of quit a little bit early as I do things. So now we'll try -3. So I'll bring down my 2. This is 2 times -3 is -6, plus 5, or excuse me, minus 5 is -11. -11 times -3 is 33, right? 33 minus 28 is what? 5. I think 33 was positive, so 5. And then -15 plus 15 is 0. So I usually give myself a little like check. That worked. Check, that worked. So now I'm going to X that off. And like I said, I'll just kind of do this like that. Because my eyes, think about it, I've gone up there like 4 times, you know. Sometimes I just forget and I go up there, you know, too many more times. So now, actually, I've tried 1, negative, or 1, 3, negative 1, negative 3. And so I'm just going to keep going, but now I'm just using this row. So generally, I draw a little line there. And this 3, excuse me, negative 3, I'm done with. So I would just go through my list 10 to 5. And so now I'm just going from here. Actually, maybe I'll just do a different color just to kind of say, I think I said I should try 5. So now I'll bring this 2 down, and then 2 times 5 is 10, minus 11 is negative 1. Negative 1 times 5 is negative 5, plus 5 is 0. Oh my gosh, that one worked also as we looked at that. And what is that as a factor? 2x minus 1. So I'll write it as a factor, 2x minus 1. And then what would the 0 be if that's the factor? 1/2. So x equals 1/2 is the factor. So could I have done synthetic division at some point with 1/2 and it would have worked as well. So there are my my zeros. Determine which if any are zeros. So my zeros are negative 3, 5, and 1/2. And I was able to find all of them. So just give me a head nod now. Do you like this? Not like it? Compared to the longer way. Can you do it, do you think, this way? Yeah. And generally, to be honest, when I haven't done one for a while, you know, like after Christmas break or something, when we come back, you know, sometimes I do, you know, my first couple this way just to kind of get myself back in the scheme of things. And then I do it like this. Although this is kind of in my head, so sometimes I want to mix them or something. So now we have just kind of a little problem to do, and we're going to solve a polynomial equation. The water level in a bucket sitting on the patio can be modeled by f of x equals x to the third. Here, I'll write that as we go. This is number 3. F of x is x to the third plus 4x squared minus 2x plus 7. Ooh, 7 looks a little funny there. Where f of x is the height of the water in millimeters and x is time in days. So this is time in days, and this is millimeters of water. Oh, height in millimeters of water. Just to kind of be able to see that way. And so then at what day will, or day or days, will the height of the water reach 10 milliliters? Or millimeters, excuse me. And so what we want to do then is we want to set this equal to 10, right? When is f of x equal to 10? And I'm going to write it this way, x to the third plus 4x squared minus 2x plus 7 equals 10. And now I'm gonna treat this like the problems that we've been doing. And so I'm gonna get one side equal to 0, and then I'm gonna find the zeros, p over q, all of my choices, and then synthetic division to kind of find what works. So I'll subtract 10 from each side, and I get x to the third plus 4x squared minus 2x minus 3 equals 0. What's P over Q? Plus or minus 1, plus or minus 3. And what's Q? Plus or minus 1. So can I go right to saying what P over Q is? It's plus or minus 1, plus or minus 3, and that's just it, right? So you know, we want to kind of, that's what we want to be writing. So the factors of this, and then if there were fractions that I could write, I'll use that as well. So our job, decide your way of doing this. I'll put a 1 there. 3, 2, 1, 0. So 1, 4, -2, -3. If you want to do it kind of the older way. If you want to do it the newer way, 1, 4, -2, -3. A line like that, and you're just putting your answers there. So take a minute and see what works. Oh, I forgot to comment on something, but I'll let you try this and then I'll comment. Does 1 work? Yes, it does. And any thoughts on what I might have said about this? X is time and days, and right. So really, since it's time and days, it can't be negative. So I had already written to try positive 1, but it can't be negative. So like, what is this? 1, 5, 3, -3, 0. So, oops. So that one did work. So day 1 is kind of what is going to happen there. Okay. Now, remember that last problem especially. There were a lot of values for P over Q, right? And it just happened that, you know, they were pretty, we came along them pretty quick, right? But there are some things to look at in this last row that can give us a hint as to when to stop kind of keeping going in that direction. So there are some, and there's another rule we'll have later, not today, but there's also a rule that kind of helps us decide if there are going to be positive or negative roots. But the rule that we're going to talk about now is a limit. And so think about the fact that these are polynomials. So do we agree, you know, that they do things like that, or they do things like this? But eventually, what happens to these out at the ends? They're going to either positive or negative infinity, right? Do you agree? So at some point, and do you also remember that when you're doing synthetic division, it can also be called synthetic substitution? So when we find that last number out there, that's like f of whatever the first number was, right? If you're not sure of that, so in this one, I didn't do them all, f of 1 is -16, correct? And we didn't do the rest of these, maybe we should have, but f of -3 is 0. That's how we knew it was a root. Well, if you're thinking about that logically, then suppose, you know, this is just at like 3, but you've got, you know, bigger numbers that are factors, 7, 21, blah, blah, blah. Well, after 3, it's never going to get near 0, right? And it's going to get super big. Or if it's this way, it's going to get super negative, right? So there's some rules that help us say, well, gosh, if you notice this, you can quit trying because this is an upper or lower bound. So an upper or lower bound is just saying that if we've tried numbers here and we're getting this kind of answer, there's not going to be any zeros out there anymore. It's going to positive infinity or it's going to negative infinity. So a lower bound is something that there will be nothing. It's just going to positive or negative infinity. An upper bound, same thing. So we have a test for this, the upper and lower bound tests. So this is a polynomial and a positive leading coefficient, and f of x is divided by x minus c using synthetic division. So the lower bound test works if c is less than, excuse me, or equal to 0. So it has to be a negative number that we're trying. And if it alternates, and so this is kind of an odd thing. So if this number is less than or equal to 0, and when you do the synthetic division, it alternates non-negative, non-positive. And the reason it says non-negative, non-positive, it doesn't have to go positive, negative, positive, negative, because they can be zeros in there. So if it can go positive, 0, positive, right? And that's still considered alternating through in that little list of numbers. Then C is a lower bound. And so if we get that kind of alternating thing, when we're down at the end there, at this end, then we can quit and not try any more negatives after that. And then if we have a positive value of C, then if every number is non-negative, so essentially, generally, they keep getting bigger and bigger, then that's an upper bound for the real zeros of F. And then there's some steps here for you to kind of think about. And lucky for you, this year yet, you get to use your graphing calculator. So you can graph it with your graphing calculator, and you can see where those boundaries are going to be. But then you have to use synthetic substitution to confirm that that's a boundary. So I do have to see that as you're doing things on tests and quizzes. And then once you've found kind of those boundaries, then you can focus in on finding those roots.